All right, awesome. Thank you everyone for coming. Great turnout. So we're here to talk about testing and specifically how we at JOOR are helping our developers test their code changes before merging them and deploying them to production. Also, leveraging containerization with Kubernetes to give developers the tools to test their code reliably and the environments for developers to preview their code changes live in a production-like environment and also for our automated tests to run against before deploying code to production. All right, so I'm Katie. I'm on the DevOps team here at JOOR. I wasn't always on the DevOps team. I started out working on our Python Django backend, and then we did a cool thing where you can do a rotation onto a different team. So I rotated onto the DevOps team, and we were doing cool stuff with Kubernetes. So I said, why not just stay? And so I stayed.
And my name is Eric Tan. I'm also doing the rotation. I started off doing the web app and moved on to the ops team and learned a lot of stuff about Kubernetes, and now I'm on the integrations team and doing a lot of ETL, but also some data ops stuff as well.
Awesome. So we've all been here. You tested your code on local and it worked great. You merged to master and you were super proud of your changes, and then your code got deployed to production, and all of a sudden everything's on fire and your DevOps team is freaking out. So as developers and as DevOps, having a local environment that's not production-like is not a good situation for anybody. How can you really predict how your code is going to behave when it goes to production if you're only testing in your local environment? And why do we have to settle for this? Why can't we have a testing environment that's closer to production? So a key focus of any CI/CD oriented team is testing. So in order to be comfortable continually releasing code changes to production, we need to first be confident that any code that's getting merged is fully vetted before it's deployed. And we should be reasonably confident that it's going to behave the same way as it did in our test environment that it's going to in production. The responsibility to test code can be a joint dev and ops effort. The developers make the code changes and make the pull requests, and the ops team supports the tools that the developers can use to reliably vet their code and then deploy it. So how do we make our testing environments actually valuable for testing developers' code? So as a developer, there's nothing wrong with testing code in your local development environment. I'd argue it's necessary. It's the most efficient way to iterate and to catch obvious bugs and to manually verify that the feature you're building has the correct functionality. But testing locally, or even testing in a lower non-prod environment like staging, cannot surface all bugs that will appear once the code has been released to production. If it did, we would never have bugs in production, which we all know that we do have bugs in production. So of course, I'm only half joking about testing in production. I think it can be done safely with the right setup, like blue-green deployments or feature flags. Generally speaking, testing your code in production is risky for obvious reasons. But how else can you get the benefit of seeing your code operate on real prod data with real prod traffic patterns and exercising code paths that only come up in real prod edge cases? So what's the compromise? How can we test safely and in an isolated way, but also know that our test results reflect how the code will behave in production once the code is merged and deployed? What if we can test our code in an isolated environment that's as close to production as possible? Crazy. So introducing the solution that we came up with, which is previews, what we call previews on Kubernetes. So we already know that Kubernetes has enormous benefits for running production applications. The replication of containers running across nodes gives us high availability. The distributed nature gives us scalability, and the fact that at the end of the day, we're just running a bunch of Docker containers gives us the feature that I want to focus on today, which is repeatability. So by repeatability, I mean that we can essentially replicate our production environment. at a smaller scale if we're concerned about cost, simply by spinning up a new namespace in the same cluster or on a new cluster and deploying the apps there. Having a separate infrastructure to test on, for developers to test on, is a huge win for the development cycle. Developers can have greater confidence that their code is production ready because they're able to see it run in an environment that's closer to production. So back to that concept of repeatability I was talking about. Let's see how that ties in with namespaces. So what's stopping developers from testing their changes in Kubernetes? We spun up a development cluster, which we call our preview cluster, which is identical to the production cluster, where developers can deploy their code in something that we call previews. It's just a namespace. A preview is a namespace, just like the main namespace. The main namespace is our production code that runs in the production cluster. And it contains all the services for our application to run. So the differences are the cluster it's deployed to and the code that it runs, as well as a cool feature that we have for testing these previews is each preview on the preview cluster has a custom URL pointing to it. So cool preview namespace has a URL that you can go to that's going to point to that application for the developer to test against. And the main namespace in our production cluster runs the Docker images built from the master branch of our code repositories, but we can deploy any image that we want to any namespace. So developers can configure their preview namespaces to run Docker images built from the GitHub branch that the developer has made changes on, which Eric will demo for us in a little bit. So what is a preview really? A preview namespace contains all the charts, values, secrets, etc. that comprise our application, packaged up in something that we call a shipment. We deploy each shipment to our cluster using a script that wraps the Helm upgrade install command. So it's just a Helm command at the very lowest level. This is all called inside a script that's called from a Docker image that we call the deployer. So the deployer has all the tools that we need installed already, such as Helm, the AWS CLI, Ansible Vault, which we use to encrypt our secrets, and kube control. And then we have a Jenkins job that utilizes this deployer image to call the script with the supplied charts, values, and secrets to deploy the namespace. So for the developer, it's just a push button, as Eric will demonstrate. And I mentioned that each preview namespace has a unique URL. So what makes this possible? We actually use a wildcard DNS record to route to our cluster Elastic Load Balancer. So both our production cluster and preview cluster are both in EKS, Amazon's Kubernetes service, and we're all over AWS. This is in Route 53. We got Elastic Load Balancer. So this DNS record routes to the Elastic Load Balancer, which forwards the request to Traefik, the load balancer within the cluster, which then resolves the request URL to the correct namespace and service based on the service ingresses. So this is handy because it allows us to have multiple namespaces on the same cluster with identical services, but requests are routed to the correct namespace using the ingress rules and the URL. So if, for example, maybe we want to make a request to the API service in our cool namespace, so we've deployed this namespace, and then we make a request to that URL, and that's how it gets routed, ELB, Traefik, and then it resolves to that namespace in pod.
Thank you, Katie. And so I'm going to go through what a developer would do on a day-to-day workflow, so if a developer makes a code change, they're going to open up a PR, and when the PR gets opened, it triggers a GitHub webhook, which will go to Jenkins, and Jenkins will create a Docker image tagged with whatever branch they name the branch on, and then in Jenkins, it'll test, well, before the tagging, I guess, it'll test everything and make sure that the code runs and all unit tests pass, and maybe some integration tests, depending on what service you've worked on. And then once that happens, a developer goes into what we call like a feature deployment repo, where they set up all their namespace and their charts shipment and can put in their configuration values, and then we use another Jenkins job to just basically ship the namespace and make it live. And I will try to do a demo. Let me see if I can just turn this off and then share the screen. Now it's going to be hard for me to talk and type at the same time. That'll be weird if you try to hold the mic for me, but. No, I'm just joking. Well, let's see if maybe you want to make it. So I made one already for coolest demo ever. Yeah.
Thanks, Eric, for that beautiful demo. I hope that change gets merged to master. I would approve it. All right. I deleted the slide. Okay, cool. So some challenges that we've encountered. We've been doing this preview workflow for several months, probably at least like 6 months. We started out on a different cluster. When we first started doing previews, we had our preview namespaces sharing a cluster with our Jenkins instance on a just singular dev cluster. That turned out to be problematic because people were deploying so many previews, it would eat up all the resources on the cluster, and Jenkins would actually have trouble running jobs because of that. We made one step further when we moved to EKS, when we had a dedicated cluster to previews and a separate cluster, a build cluster just for Jenkins to use. So we separated those out, and then we ran into another issue, again with resources. So we neglected to allocate enough IP addresses. We made our subnets too small in our preview cluster, and unfortunately you can't change that on a live cluster, so we had to recreate our preview cluster, which was actually pretty seamless. But that was something that we did to resolve the resource issue, and it seemed to be a little bit better now. Sorry? It's about as big as you can get. It's 2 subnets /17. So, and a VPC can only be /16. So. Mm-hmm. And also, it took a little while for us to get developers on board with using this workflow. So when the previews were sharing a namespace with Jenkins, we obviously couldn't give everybody access to that cluster, kube control access to that cluster, because we wanted to protect our Jenkins instance. But once it was on its own preview cluster, we kind of loosened up that circle of trust and gave developers full access to the cluster. So again, it's kind of a trust system, like you don't delete someone else's namespace, which has worked out pretty well so far, unless I have to delete a namespace, and I will not be, I will not be merciful. So, developers have kube control access to the whole cluster. They can debug their own namespace, which has been really great. People are really taking advantage of kube control, looking at logs and stuff. So that's sort of how we've empowered people to use Kubernetes. Some other things that we're sort of working on now, or planning on working on, automatic shipment. So that Jenkins job that Eric showed, we are currently working on a process to automatically create that shipment namespace when you create a PR and deploy the namespace. So that eliminates a lot of the manual work involved with changing the values.yaml, changing the branch that the shipment points to. And we're also planning on putting the preview namespaces behind a VPN. Right now they're accessible to the world, so you can go to mycoolnamespace.joordev.com and have a look around. So we're working on putting those behind a VPN, so they're only accessible within the office. Deploying only green builds. So another cool thing about the way we set this up is we have the ability to run our automated test suite against these preview deployments. So we can run like our end-to-end test suite, and we have a special namespace for that, which we call QA dev. And that gets deployed automatically with every merge, and the end-to-end tests run against that. And ultimately, the goal is that if the end-to-end tests fail, that will mark those images in that build for not okay to deploy if it fails, or if the end-to-end tests pass, then they'll be marked okay to deploy, and we'll deploy that manifest. And we also have another project underway to improve the data set that people are using for their preview deployments. So currently, there's an option to connect your preview deployment to a Postgres container, which is run with a image that contains a very small subset of sort of seeded data just for very, very basic testing, or you can connect to a remote shared RDS instance that contains, again, a small set of data. It's a little bit larger, but it's still not production-like. So that could really improve our developer experience if they have the data set available to test their code against. So we've shown that we've created a testing environment that's similar to production. The ability to test manually and automatically in a prod-like environment has proved invaluable for us in catching bugs that otherwise might have made it to production. So we're lucky that Kubernetes makes this really easy. But the idea is simply to invest in creating a place for developers to test that's as close to production as possible. And you won't find yourself saying this every time you deploy to production. So that's it. We are hiring. This is our career page, and that's our blog page. Thank you.
What's a shipment again? Is that just a set of Helm charts that comprise your whole application?
Yeah, a shipment is basically just everything you need to make your namespace. So it's the charts, we had that requirements.yaml, it's the Helm charts, it's the values file, and it's the secrets that are all sort of packaged together in a way that our deployer can just ship them up with one Helm command.
So I do something similar. I build like a platform, right? And I have different sets of developers, right? And they're making different microservices, right? And this person makes a microservice, and so I'm thinking you're taking that developer's microservice, right, and deploying it into a system that has all the stable microservices from the other development team. That's a shipment, right? It's a packaged application with just one change.
Yeah, exactly. So we have a chart. We're not exactly at microservices yet, but we're working towards that. We have a chart for each of our sort of applications. So the API, our Django backend, React. So those are all different charts, and they all have different sections in the values file. And they default to using the master branch on each. But as Eric showed, you can change one of them to point to your own custom branch.
Gotcha. All right. Thank you.
Yeah.
What is the infrastructure stack in terms of how everything fits together? I know you're using Kubernetes, you're using Jenkins. Where does it sit on the OS? How the code gets flown through all the different infrastructure parts? If I was basically putting together an infrastructure from scratch, how do you guys do it?
Yeah, so our Kubernetes clusters are running on Amazon, so they're EC2 instances, and then each namespace is basically a collection of pods that are running different Docker containers. So we have like a Django pod. We have a legacy PHP app that contains a reference to our React package application. What else? Django, React.
Integration services as well. And then we have an integration services where the team that the infrastructure that I'm most familiar with that also uses Django, but we also it's just different versions of Django, like different copies of Django with different code bases that we use. That's all. But mainly infrastructure level. That's pretty much what she said.
You use AWS, right?
Yeah.
How about if you had to do it as on-prem? Because I worked in a financial company, and they can't, because of federal regulations, they can't put this stuff in the cloud.
Interesting.
I've never heard of a Kubernetes cluster running on-prem, but if anyone's doing that, that'd be really cool. Yeah? Yeah?
Yeah, there's a bunch of options. OpenShift, we'll be doing stuff with NetApp, what else? Pivotal. Pivotal. Yeah. Exactly.
Yeah, so I had two questions. So one surrounding your entire pipeline here. For instance, is there anything that reaps old namespaces? So say you've had something that's sat there for 6 months, will it sit there for another 6 months, or will you go and clean that up after a period of time?
Yeah, that's a great question. I think I mentioned our Jenkins job that it's just run on a schedule. It automatically deletes namespaces that are older than 2 days. But if that job fails for some reason, it will not delete those namespaces.
Fair enough. And how do you go, or can you go about using your same testing pipeline to test changes to Helm charts or different infrastructure components and that kind of stuff?
Yeah, we're actively working towards that. Like I talked about that deploy only green builds project. That's where, the code changes, you test against them, they pass the EDE test, whatever. We would also love to have that same setup for Helm chart changes, because there have been not 0 cases where a Helm chart has broken prod. So that would be awesome if we can get to that point.
Do you do like vulnerability analysis on your Docker images?
Sorry, can you say that again?
Like vulnerability analysis? Like
Vulnerability analysis?
Security.
I don't think so.
Really secret though. They don't even know about it.
Yeah, we're working towards where we actually have automated. So like, I would love to get to the situation where when you spin up a preview, it can run security scans, maybe external. Also just like scaling scans, performance scans, so making sure latency doesn't increase. So there's like first just the functional changes that we need to make sure are working, but also just making sure everything else is looking good. But we're getting there. But yes, we do security scans. That's the line item. Keep repeating it. What? We use an external firm, and then they hire a pen tester and stuff like that.
Why didn't you use EKS and why are you using? Yeah.
It's because we were married to it.
We were using StackPoint before. Yeah, we started out on StackPoint, and every time we asked them for help, they never responded. So even though they're like, what, $50 a month? 15?
That's what it was.
Yeah, $50 a month.
$50 a month.
I don't know. It wasn't worth it.
Yeah, you guys, you taught us in the middle of the transaction.
Okay.
Try us again, please. Only NetApp this time, man.
I'm curious if you're using Helm hooks or the Helm test command at all.
Not that I know of.
Helm. Helm. What do you mean by Helm hooks? Can you explain?
So you can have like a pre-install,
Oh, yeah.
post-install, pre-delete.
So we are using post-install. One of our other developers created a post-install chart where it's used to run migrations before we start one of our services, and that's been actually pretty useful lately. And what was the other Helm test? Yes. Is that for like linting the charts? No.
Well, there is a Helm link.
Yeah, there's that. Okay.
But test can run any. You can annotate a pod with the Helm test annotation, and then have it run. When you run the Helm test command, it'll run the pod in the cluster, and then if the pod exits 0 or 1, it'll report back on the CLI.
Interesting. Okay. Good to know.
I'll ask one. So EKS, can you give us a lowdown on your experience with it so far? You're using EC2 instances and spinning up your own clusters. I'd love to hear more about it.
Yeah, the thing that's made EKS really possible for us has been Terraform, honestly. I was talking about we had to recreate our preview cluster because we needed more IP addresses. That was literally pressing enter in Terraform. So that's all been really easy. Spinning up a cluster at a press of a button has been awesome. So yeah, I mean, it was also a matter of like you're kind of at mercy of like whatever version of Kubernetes they want you to be on. So They had rolled out like some update for horizontal pod auto scaling, and they were like, oh, we'll eventually update all live clusters, but you'll have to, like, new clusters will have the update. So that's another reason why we recreated our cluster, was because it was kind of like, when are you gonna update this for us? It was unclear. But otherwise, I mean, I don't know. We've had just general Kubernetes struggles here and there, but I think overall EKS is pretty good. We didn't, because, I mean, another reason why we chose EKS was because we're fully on AWS already. So if we were to go to GK, it would be kind of maybe all or nothing.
An RDS live with no downtime. Tell me that.
Yeah. Yep.
All right, cool. Thank you so much for that. By the way, don't email